If greater civilizations exist, their influence should leave traces scattered across the universe. The challenge is learning to recognize patterns designed to remain invisible to minds at our current stage of development. Advances in data analysis and machine learning are now exposing anomalies that earlier generations of scientists could not see. Take the fine structure constant, the number that governs the strength of electromagnetic interactions. Across cosmic distances and epochs, it appears astonishingly stable, far more so than chance would suggest. Traditional physics explains this with anthropic reasoning. If it weren't so, we wouldn't be here to observe it. But the zoo hypothesis hints at something more unsettling. What if these constants don't remain fixed on their own, but are actively maintained within narrow ranges to preserve the conditions required for our growth? That would mean every law of physics we discover, every mathematical relationship we define, exists only inside a carefully managed bubble of space-time. Our entire scientific worldview could rest not on the true universe, but on a curated version designed to sustain developing minds like ours. This possibility reframes certain cosmic puzzles. The distribution of gamma-ray bursts reveals suspiciously quiet regions. The isotopic ratios in nearby stars sometimes deviate from expected models of stellar nucleosynthesis. Even the cosmic microwave background, when examined with extreme precision, might hold fingerprints of vast engineering projects disguised as natural phenomena. These irregularities are the beginnings of what some researchers now call cosmic archaeology, the search for traces of ancient construction hidden within astronomical data. Just as archaeologists infer past civilizations from soil chemistry and settlement patterns, we might one day identify alien megastructures from subtle distortions in light, matter, and energy. Civilizations working on galactic timescales may leave fingerprints even while trying to conceal themselves from younger species. The real difficulty is distinguishing between natural cosmic processes and artificial ones designed to look natural. Truly advanced societies would not build obvious structures like Dyson spheres which any telescope could detect. Instead, they might develop ways to harvest stellar energy while keeping the star's outward appearance intact, or construct transportation systems camouflaged within black holes and neutron stars. Perhaps what we call dark matter and dark energy, the mysterious forces that make up 95% of the universe's content, are not unknown physics at all, but the side effects of technology so advanced that we mistake them for the fabric of reality itself. And then there's the strange timing of our own development. For millions of years, human technology changed little. Yet in only a few centuries, we leapt from horse-drawn carts to spacecraft, from mechanical calculators to artificial intelligence rivaling the human brain. This exponential acceleration could be a natural pattern, or the result of subtle guidance. Our scientific revolutions often arrive in clusters, with discoveries converging to unlock entirely new eras of progress. History shows uncanny examples of simultaneous invention. Newton and Leibniz developing calculus independently, Darwin and Wallace formulating evolution in parallel, physicists across different countries arriving at quantum mechanics at the same time. Such coincidences may not be coincidences at all. They could reflect prearranged pathways, nudged forward by unseen hands. Imagine this: each breakthrough, each sudden leap in innovation, may represent carefully timed interventions, ideas introduced just as humanity is capable of handling them. To us, they feel like chance or genius. To them, they may be the calibration of a long-term educational program. So tonight, when you look up at the scattered lights of the cosmos, remember, you may not be gazing into an empty void. You may be peering through the bars of the most advanced sanctuary ever constructed, observed by minds whose understanding of reality eclipses anything we can imagine. Whether we are alone, sheltered, or standing at the edge of a hidden cosmic filter, one truth remains. The choices we make in the coming years will echo across timescales that dwarf human history. We are writing the story of consciousness. And the universe may be watching. What if our place in the galaxy is not an accident but a choice? Patterns in the distribution of heavy elements, the stuff planets and life are made of, could point to large-scale engineering that seeds certain regions with what life needs. Even our home, orbiting inside the Milky Way's so-called habitable zone, sits in a sweet spot, far enough from the violent galactic center to avoid sterilizing radiation, yet close enough to benefit from generations of stellar alchemy. That balance looks almost engineered, optimal for nurturing life rather than the random outcome of chance. Timing matters too. We've emerged in an era when the cosmos is chemically mature enough to host complex, stable worlds, but not yet so spread out that communication across galaxies is impossible. Advanced civilizations might have identified this narrow window of habitability as the ideal time to foster new minds, beings that could one day contribute to a vast, collective project to preserve and understand intelligence across the universe. Seen through that lens, humanity's role grows huge. Our struggles, discoveries, and even failures become data, contributions to a cosmic archive of how consciousness develops. Each scientific insight, each act of compassion, and each mistake could inform countless future civilizations. The idea is intoxicating. Nothing we do would be wasted, but with that promise comes a weighty responsibility. If we are part of a larger education or stewardship program, our choices about technology, governance, and empathy may influence not only our future, but the evolutionary path of intelligence in our region of space-time. That may explain the apparent restraint of any observers. Direct intervention would relieve immediate suffering, but could rob us of the resilience and wisdom necessary to survive as members of an interstellar community. Global crises, climate breakdown, nuclear proliferation, runaway AI, might be treated as tests, calibrated to reveal whether we can solve existential problems without outside rescue. From this angle, pandemics, social fragmentation, and the ethical puzzles of genetic engineering are not random calamities, but trials that measure our capacity for sustained, responsible action. The criteria for passing such trials may be subtle. Observers might not just score outcomes, they may assess how we proceed. Do we favor long-term cooperation over short-term advantage? Do we build institutions capable of stewarding life across generations? Do we develop technologies that enhance human dignity instead of eroding it? These are not merely technical milestones, but moral and psychological thresholds that can only be reached through lived experience. What happens if we fail? Advanced watchers could judge that humanity lacks the qualities required for safe membership in a broader cosmic society. In that case, our isolation would not be mercy, but a verdict, a decision that we must face our technological challenges unaided. The silence from the stars could endure forever, not because no life exists, but because the life that sees us deems us unready. That possibility is sobering. Yet even if contact never comes, the very prospect of being observed changes how we act. Every choice to cooperate rather than compete, every decision to prioritize long-term survival over short-term gain becomes part of a legacy that might outlast our species. There is a darker interpretation too. What if Earth is not a sanctuary but an experiment? In this laboratory variant of the zoo idea, our history, wars, religions, scientific leaps, and environmental crises could be variables in deliberate tests crafted by beings seeking to understand consciousness, culture, and technological emergence. From this viewpoint, UAPs, odd signals, and faint anomalies in astronomical data might be designed stimuli to probe our reactions. The frequent ambiguity of such evidence, signals that entice but never confirm, would make sense if observers intentionally keep their interventions just below a threshold that would force open acknowledgement. That hypothesis raises profound ethical concerns. On Earth, responsible science demands informed consent. Subjecting unwitting populations to experiments would be unconscionable. But alien ethics might not map to ours. Civilizations billions of years ahead could conceive of identity, personhood, and value in ways that make our notions of autonomy seem parochial. Some defenders of the experimental view argue that extremely advanced intelligences might think in terms of species-level welfare or even networked, post-individual minds, perspectives that could justify interventions we would never accept. There is yet another, more hopeful possibility: integration. Perhaps the ultimate aim is not control but inclusion, preparing emerging minds to join a vast web of intelligence. Rather than a community of competing polities, the universe could host a distributed network of minds, a collective intelligence whose nodes are whole civilizations. Integration into such a web would demand not only technology and institutions, but a readiness to preserve the distinctiveness of human consciousness while contributing to a larger awareness. That's a tall order. To merit that invitation, we might need to show we can maintain individuality and creativity while participating in a shared intelligence, something that would take centuries or millennia of cultural, psychological, and technological maturation. As unsettling as these scenarios are, they transform our immediate crises into something more. Not just do-or-die struggles for survival, but opportunities to develop the virtues required for cosmic stewardship. If this is true, our era, fraught and fragile, could be the phase when we either demonstrate the wisdom to steward intelligence across time or reveal the limits of species-level maturity. So what should we do now? Keep building better science, yes, but also cultivate institutions that prize long-term thinking, nurture global cooperation, and align technical progress with ethical maturity. Whether or not we are observed, acting as if we are accountable to future life, ours and others, changes what we choose to invent and how we care for our planet and one another. The search for those definitive signs has already begun. Scientists analyze subtle anomalies in cosmic radiation, isotopic ratios, and galactic structure. Some researchers have argued that patterns we currently explain with unknown physics might instead be signatures of vast engineering. Whether those hints point to guardians, experimenters, or nothing at all, the questions they raise force us to confront our responsibilities with fresh urgency. In the end, the grandest question remains, will intelligence prove capable of wisdom? The cosmos appears to be watching, not just to tally our inventions, but to judge the moral shape of our choices. Whatever the verdict, the story we are writing now may echo far beyond the limits of this world. In some scenarios, multiple species might be observed simultaneously from carefully chosen vantage points. The distribution of heavy elements essential for planet formation shows striking patterns, ones that could suggest massive engineering projects designed to seed regions with the building blocks of life. Even our position within the Milky Way may not be random. We orbit within what astronomers call the galactic habitable zone, far enough from the galaxy's violent center to avoid sterilizing radiation, yet close enough to benefit from the chemical enrichment produced by countless generations of stars. Such positioning appears almost too perfect for chance, perhaps not luck at all, but careful placement in a region optimized to nurture intelligence. The timing of our emergence may also be deliberate. Humanity is developing at a point when the universe is chemically mature enough to support complex life and stable planetary systems, but before cosmic expansion makes intergalactic communication impossible. This window of habitability could have been identified long ago by advanced civilizations as the ideal era for fostering new consciousness, minds capable of contributing to a collective project of understanding and preserving intelligence throughout the cosmos. If this perspective holds true, then humanity's role stretches far beyond mere survival or reproduction. We may be strands in an immense network of consciousness, spanning billions of years and countless worlds, each offering unique insights and abilities. Our struggles with existential risks, our efforts to uncover the nature of reality, and our attempts to create meaning in our lives may all become part of a shared knowledge base, guidance for future civilizations navigating their own growth. The beauty of this vision lies in the idea that no conscious experience is wasted. Every moment of awareness, every creative insight, every triumph, and even every tragedy adds to the universe's understanding of itself. Failures teach caution. Breakthroughs point the way forward. In this framework, the responsibility we carry is staggering. If we are part of such a grand educational system, then the choices we make about technology, the environment, and society ripple outward, affecting not just humanity, but the trajectory of intelligence across space-time. Perhaps this explains why potential observers keep their distance. Intervening directly might ease our immediate suffering, but it could also rob us of the resilience and wisdom needed for long-term survival as cosmic citizens. Global challenges like climate change, nuclear weapons, and artificial intelligence may not just be random threats, but carefully designed tests of maturity, lessons we must face unaided. From this perspective, every crisis humanity endures becomes a kind of exam. The COVID-19 pandemic, tested our ability to coordinate across borders. The explosion of digital media probes whether we can maintain social trust and shared truth in an age of information overload. Our use of genetic engineering and synthetic biology reveals whether we can reshape life itself with wisdom rather than recklessness. The criteria of these cosmic tests may be subtle. Observers might not only ask whether we solved a problem, but how we solved it. Did we prioritize compassion, sustainability, and foresight, or did we stumble into solutions driven by short-term gain? This could mean that the timing of contact is not tied to technological milestones, but to demonstrations of wisdom that can only emerge through lived experience. Perhaps we will need to prove that we can cooperate globally, uphold ethical principles under pressure, and make choices that favor survival over convenience. Such a trial might last centuries, far exceeding our expectations, because from a cosmic perspective, humanity may still be in its earliest developmental stages. What happens to civilizations that fail? Some may destroy themselves through war or ecological collapse, becoming cautionary tales for others under observation. Yet those who show potential might receive subtle guidance at critical moments, breakthroughs appearing as strokes of luck, scientific revolutions arising at just the right time, or insights granted to individuals who become catalysts for progress. To us, these may look like coincidences or flashes of genius, but they could be the carefully calibrated nudges of unseen mentors, hidden just below the threshold of certainty. Such interventions would need to be incredibly sophisticated, blending help with challenge, survival with independence. They must appear natural, not imposed, so that humanity retains a sense of ownership over its progress. This requires not only advanced technology, but also an unparalleled understanding of psychology, sociology, and history. Perhaps the greatest test of a civilization is not simply whether it can survive, but whether it can one day guide others without robbing them of their own path. In this sense, humanity's destiny may not be just to endure, but to become a teacher for future species, passing forward the lessons of our triumphs and mistakes in a chain of wisdom stretching across the galaxy. Our current crises, then, are not isolated problems. They are part of the curriculum. Every advance in sustainability, every breakthrough in conflict resolution, every innovation in education and governance could serve as knowledge for countless other species yet to come. The responsibility is enormous, but so is the potential legacy. As we confront nuclear proliferation, climate instability, AI development, and biotechnological power, we are writing textbooks for civilizations we will never meet. Our legacy may reach far beyond Earth, shaping the very evolution of consciousness in the universe. If so, then the stakes of our choices today are nothing less than cosmic. The zoo hypothesis in this light becomes not an experiment in secrecy, but an interstellar classroom, one in which humanity is both the student and, one day, the teacher. This perspective could explain why our cosmic observers might maintain such flawless discipline in avoiding early contact. If their goal is to help emerging species develop genuine wisdom and self-reliance, then offering easy answers or outside aid would only sabotage the process. Like parents watching their children stumble so they can learn essential life lessons, advanced civilizations may recognize that young species must navigate their own technological adolescence without intervention. Seen this way, the zoo hypothesis becomes less about secrecy and more about education. Contact may still come, but only after humanity has proven it can survive its existential risks without external rescue, managing nuclear power responsibly, building sustainable relationships with its planet, and creating stable social systems capable of lasting across geological timescales. From a cosmic perspective, our progress has only just begun. What looks like impatience to us, because we measure time in decades or centuries, might to them seem like the earliest stages of growth, judged on scales of millennia, or even millions of years. From our limited view, the silence of the stars feels like neglect. But from theirs, it may represent the most careful form of nurturing, an extended educational program guiding species toward long-term survival. That raises new questions. Are we being prepared for integration into a wider galactic community, or shaped toward outcomes that serve the interests of our observers? The line between benevolent guidance and subtle manipulation is nearly impossible to discern, especially if interventions are designed to appear as natural. Development civilizations with millions of years of experience could possess unparalleled insight into which traits determine whether a species thrives or collapses. They may have identified markers of survival, not flashy technologies, but deeper capacities like empathy, creativity, or abstract reasoning, cultivated only through cultural and intellectual challenges. True success might require balancing individual ambition with collective cooperation, or technological power with philosophical wisdom. If so, our observers would have every reason to remain hidden until those qualities clearly emerge. Early contact, no matter how helpful it seems at first, could cripple our chances in the long run. In this light, what appears as neglect may instead be the most advanced form of care, maximizing our chances for survival and flourishing. Humanity may be part of a vast educational chain spanning billions of years and countless worlds, where each species serves first as a student, then eventually as a teacher to those who follow. This cumulative wisdom could explain how the zoo hypothesis works across immense timescales without requiring active coordination. What we see as silence may actually be the legacy of civilizations long past, who designed durable protocols for guiding emerging intelligences. If so, then humanity is not just another isolated species. We are a data point in a galactic-scale experiment, our triumphs and failures feeding into an ever-growing body of knowledge about how consciousness survives in the universe. The ore of this idea lies in its duality. Our struggles could hold immeasurable importance, shaping guidance for civilizations yet to come. But it also forces us to ask, are we truly free agents or merely walking a path designed by forces beyond our comprehension? Perhaps both are true. Even if our growth unfolds within parameters established by others, the experiences themselves remain authentically ours. The love we feel for our families, the wonder of gazing at the stars, the satisfaction of solving a complex problem, all retain their meaning, regardless of cosmic design. The real test may not be whether we can build certain technologies or solve certain crises, but whether we can preserve a sense of purpose and meaning while accepting the possibility that we are students in a cosmic classroom, one where the teachers remain forever out of sight. As our tools advance AI, quantum physics, deep space telescopes, we may one day gather enough evidence to confirm or reject the zoo hypothesis. Until then, we are left with the unsettling but exhilarating task of asking what it means to live, create, and strive for meaning in a universe that may be far more carefully arranged than we ever imagined. Human civilization now finds itself at a turning point. For millennia we advanced slowly, but in just a few centuries we've leapt from animal power to spaceflight, from primitive tools to artificial intelligence systems that may soon outpace human cognition. The question is not whether this acceleration will reshape us, but whether it is happening under our own direction or under the quiet observation or even influence of others. If advanced civilizations are indeed monitoring us, this moment would be their prime focus. We are approaching thresholds in biotechnology, energy systems, and AI that could make us capable of reshaping our planet or destroying ourselves. To those watching, the way we handle these challenges might determine whether we graduate from isolation or whether our development triggers direct intervention. Criteria for such decisions might include our ability to manage existential risks, the maturity of our social and political systems, or our handling of transformative technologies. Critics of the zoo hypothesis, however, highlight a glaring problem of timing. If protocols of non-interference were established millions or even billions of years ago, how could such perfect coordination be maintained across vast stretches of time? Civilizations rise and fall, political systems evolve, ethical frameworks change, and technologies advance in ways that make ancient rules nearly impossible to preserve. The idea assumes not just initial agreement among multiple advanced civilizations, but unwavering adherence across epochs longer than all of human history. It also assumes that every civilization would converge on the same ethical conclusion about how to treat emerging species. That runs against everything we know about the diversity of moral thought, even on Earth. Some cultures have prioritized protection, others exploitation, and still others indifference. It seems unlikely that alien civilizations shaped by entirely different evolutionary pressures, would all land on identical values. This creates what researchers call the zoo escape problem. It only takes one civilization to break the non-contact protocol for the entire system to collapse. Motivations could range from scientific curiosity to territorial expansion, resource needs, or simply different ethical reasoning. The fact that open contact hasn't happened could mean perfect eternal coordination, a scenario that seems implausible, or that the hypothesis itself is flawed. Detractors argue that the probability of such coordination persisting across multiple civilizations and cosmic timescales is vanishingly small, making alternative explanations more likely. Supporters counter that this criticism assumes we can understand the motivations and capabilities of civilizations far beyond our own. In reality, we may be projecting human limitations onto entities with forms of intelligence and organization unimaginable to us. Perhaps they have developed collective decision-making structures that transcend competition, or intelligence systems that integrate across species and even worlds. Their political coordination might operate on million-year cycles, rendering our concerns about short-term stability irrelevant. It's also possible that the coordination is not active at all, but automated. Civilizations that mastered technology long ago could have built self-sustaining systems designed to monitor and manage emerging species indefinitely. Such systems would not need constant oversight. They could quietly enforce protection protocols, track development milestones, and act according to the programming established by their creators, even long after those creators vanished. This automated zoo model resolves many of the coordination challenges, but raises new questions about the nature of intelligence on cosmic scales. If our development is being guided by such systems, then our history may be unfolding along paths set by entities we can no longer see or even comprehend. That possibility strikes at the heart of free will and self-determination. Are our scientific breakthroughs and cultural achievements truly our own, or are they outcomes anticipated and even nudged by unseen architects? If the zoo operates through hidden interventions, subtle influences on when key discoveries occur, or which individuals emerge as innovators, then humanity may not just be the animals in the enclosure, but the participants in an experiment we cannot access or understand. And yet, even in such a scenario, human experience does not lose its meaning. The emotions we feel, the relationships we form, the creativity that drives our art and science, these remain real regardless of the larger framework in which they unfold. The value of consciousness and lived experience may be intrinsic, not dependent on whether our environment was shaped by nature alone or by alien design. Still, the search for evidence continues. With each advance in telescopes, AI, and quantum sensors, our ability to detect subtle traces of extraterrestrial technology increases. Anomalies in cosmic radiation, suspicious isotopic ratios in stars, unexplained patterns in galaxy distributions all may be the fingerprints of advanced civilizations, hidden in plain sight. The real question is whether we are ready to face what such discoveries imply, that our species, and perhaps all our history, exists under the gaze or even the guidance of intelligences whose capacities stretch far beyond our imagination. Would you like me to also summarize this last long section into a concise, narrative-friendly transcript, like a YouTube voiceover, so it flows more naturally for video use? If we're being watched without our knowledge, what rights, if any, do we have over that observation? Do we truly retain the freedom to develop naturally, or is our progress being steered within artificial limits set by some alien zookeepers? And most unsettling, what happens if those advanced caretakers decide our behavior has become problematic or dangerous? There's a darker twist to the zoo idea. Ball himself sketched a version called the laboratory hypothesis, in which Earth functions less like a passive exhibit and more like an experimental testbed. In this scenario, extraterrestrial intelligences could be running controlled experiments on our technological, social, or even biological evolution. Their interventions could range from subtle nudges that bias historical outcomes to active manipulations, introducing particular technologies at critical moments, influencing major events, or even performing genetic changes that later look to us like natural evolution. Viewed this way, the reluctance to contact us might not be paternalistic kindness, but a scientific imperative. Direct interference would spoil the data. If the goal is to learn how a civilization naturally transitions from local to interstellar, preserving experimental integrity could require keeping the subjects isolated until they reach predetermined conditions. This framing makes some otherwise mysterious phenomena eerily plausible. Repeated reports of unidentified aerial phenomena, including sightings by reliable witnesses such as military personnel, might represent monitoring operations or experimental activity by whatever is studying us. Recent governmental disclosures about UAPs document hundreds of encounters involving craft that display flight behavior beyond current human capability. Officials may deny extraterrestrial origins, but the patterns described are consistent with a surveillance program. Objects showing extraordinary acceleration, instantaneous changes in velocity, or movements that would be lethal to any human pilot. Many sightings occur near military facilities or during weapons testing, which could suggest systematic observation of our most advanced technologies. The timing may not be random. As humanity develops sharper detection systems and nears breakthroughs in fields like AI or fusion, the Watchers might ramp up reconnaissance to determine whether we've crossed thresholds that would prompt a change in their monitoring or engagement protocols. Still, the zoo hypothesis draws serious criticisms. For one thing, maintaining a galaxy-wide agreement to avoid contact would require an unprecedented level of cooperation among potentially millions of distinct civilizations, each with its own culture and motives. An implausible feat, critics say. The hypothesis also presumes that human civilization is sufficiently interesting or important to warrant monitoring, a stance that smacks of anthropocentrism. After all, enormously advanced societies might have concerns, goals, and priorities utterly alien to our understanding. We could be as insignificant to them as ants are to human urban planners. Moreover, the zoo idea seems to conflict with the Copernican principle, the long-standing notion that Earth and humanity are not in a privileged position in the cosmos. Defenders respond that the Copernican argument can cut both ways. If intelligent life is common, it's plausible that some civilizations have advanced so far beyond us that they've developed protocols for handling emerging species. Our apparent ordinariness might be precisely why we're preserved, a typical specimen worth watching. To place the zoo hypothesis in context, we should contrast it with other leading explanations for cosmic silence. Economist Robin Hanson's Great Filter conceives of one or more nearly insurmountable barriers somewhere along the path from raw chemistry to star-faring civilization. If the filter lies behind us, we are astonishingly lucky survivors. If it lies ahead, we may be marching toward doom. Every major technological leap, nuclear weapons, climate collapse, artificial superintelligence, engineered pathogens, could be the kind of catastrophe that wipes out species just as they approach interstellar capability. Then there's the dark forest picture, borrowed from Liu Cixin's fiction, which is even more chilling. In that view, the galaxy is a hunting ground. Every civilization conceals itself because announcing your presence risks annihilation by a more powerful neighbor. Discovery becomes existentially dangerous. Even a peaceful species might destroy you in order to preempt a future threat. If every society reasons this way, the first to be noticed is the first to die. Under that logic, our SETI-style broadcasts and outward-facing signals could be fatal beacons, needless flares in a lethal wilderness. These hypotheses imply radically different futures for humanity. The Great Filter paints us as either miraculous survivors or doomed soon-to-be victims. The dark forest makes us prey. The zoo hypothesis suggests we are protected, or at least observed, in a carefully managed preserve. Each model also yields different expectations about what we should see. Recent advances in astronomy and the spate of UAP reports could, depending on interpretation, support any of these scenarios. If the zoo view is correct, many of those UAP encounters, especially near military sites and during weapons tests, could be routine surveillance sorties by civilizations tracking our military, technological and industrial capabilities. The reported flight characteristics, if accurate, imply technology far beyond our physics and engineering. From the zoo perspective, That would be precisely what one would expect. Watchers whose tools appear magical to us, operating at a level achievable only by civilizations millions or billions of years ahead. None of these ideas is free from logical difficulties or unsettling implications, but taken together, they frame a set of testable expectations and moral questions. Are we being protected, experimented upon, stalked, or simply ignored? The data we gather in the next decades, both from telescopes and from careful study of UAP reports, may help tip the balance toward one answer or another. Imagine it's 1950. Four leading physicists stroll to lunch at Los Alamos, casually trading observations about recent UFO reports. As they settle in, one of them, Enrico Fermi, drifts from joking conversation into a startling thought. Our galaxy alone contains some 200 billion stars. Given billions of years of cosmic evolution, the opportunities for life to arise and spread seem enormous. Then Fermi asks the question that would haunt generations. Where is everybody? Those three words hide one of science's most unsettling puzzles. When you combine the mind-boggling scale of the universe with the vast time since the Big Bang, it seems almost inevitable that intelligent life should exist elsewhere, and that we should see evidence of it. Our telescopes ought to pick up broadcasts, or vast astroengineering projects, or other unmistakable signs of advanced civilizations. Yet the cosmos remains eerily quiet. Tonight we'll examine one of the most provocative answers to that silence, a hypothesis that suggests we might not be alone at all, but rather carefully hidden. Picture a cosmic preserve, highly advanced alien societies observing us from afar, deliberately avoiding contact. Like scientists watching wildlife without disturbing it, these civilizations could be monitoring humanity while keeping their presence invisible. This idea is not mere science fiction. It has been proposed seriously by astronomers and astrobiologists. It also offers a way to think about recent puzzling reports of unidentified aerial phenomena that have even baffled trained military observers and prompted government statements. The story begins with that 1950 question, but as our cosmic knowledge has expanded, the implications have become more disturbing. Every new discovery about exoplanets, the prevalence of water-friendly worlds, and the widespread distribution of life's chemical building blocks strengthens the expectation that life should be common, yet no clear signs appear. Traditional explanations range from hopeful to grim. Maybe intelligent life is incredibly rare. Maybe civilizations self-destruct before going interstellar, or maybe hostile hunters wipe out emerging species. But in 1973, astrophysicist John A. Ball from Harvard offered a radically different idea, the zoo hypothesis. Ball asked us to overturn our assumptions about extraterrestrial behavior, to accept that other intelligences might be aware of us and intentionally keeping their distance. The zoo analogy is simple but chilling. Think about how researchers study animals in the wild. They hide, build blinds, use long-range lenses and remote sensing so they can observe natural behavior without interference. Scale that approach up to galactic proportions. Civilizations millions or billions of years ahead of us would possess technologies far beyond anything we can imagine. Methods of concealment and observation that render them invisible to our instruments. They could be watching quietly, ensuring their probes and signals leave no detectable trace. Ball recognized how psychologically unsettling this is. For decades, many assumed that if aliens knew about us, they would enthusiastically make contact. But that assumption is anthropocentric. Advanced societies might have good reasons to avoid interfering with less developed species. History on Earth shows why. Contact between technologically unequal peoples often devastates the less advanced group. Disease, cultural collapse, social disintegration. Perhaps alien civilizations learned similar lessons and adopted protective, non-intervention policies. Under the zoo idea, aliens might only permit contact once a civilization reaches certain technological, political, or ethical milestones. For instance, the safe management of nuclear arms, successful global cooperation on climate, or signs of social maturity that indicate readiness to join a larger galactic community. This mirrors tropes from science fiction. Star Trek's Prime Directive is a familiar example, but Ball's proposal moves beyond fiction. He suggested a systematic galaxy-wide effort to shield emergent species like ours, using barriers and concealment so effective that we might doubt their very existence. If the zoo hypothesis holds, it would force us to rethink everything we believe about our place in the universe. We would not be alone in a silent void, but instead be part of a carefully managed preserve, observed by intelligences so advanced that their presence is undetectable by our current science. That raises difficult ethical questions about consent, autonomy, and the right to be left undisturbed. Questions we'll start to confront as we continue this exploration.